Alright guys, we're going to talk about redox today. If you remember, we've talked about different types of reaction: combination, decomposition, single replacement, double replacement, and combustion. And all the reaction except double replacement reaction are under redox. So combination, decomposition, combustion reaction, single replacement reaction, those are all under the redox reaction. Double replacement reaction, those are not under redox reaction. Now, so we're going to talk about what is this redox reaction. So redox reaction is this big umbrella of reaction. A lot of things are under the redox reaction, under the umbrella of redox reaction. Now, redox has two parts, and that's very key. There is an oxidation and there is reduction. So when you have a redox reaction, oxidation and reduction has to happen at the same time. Okay. Now, how did they come up with the word redox? OX and RED, chemists. Sometimes we're not that creative, so you put it together and then you're going to get redox. Now, what is oxidation? What oxidation is loss of electron. And what reduction is, you can probably guess, is gain of electron. So what redox is a movement of electron, is a transfer of electron. And because of that, the charges will change. Because if you remember, when you gain or lose electron, the charges change, right? So redox is a transfer of electrons, a movement of electrons, and the charges will change because the electrons are moving around. If you lose electron, you become more positive. You already knew that. When you lose electron, you become more positive. Now, when you gain electron, you become more negative. Okay. So, redox is a movement of electron, and the charges will change because one is going to lose electron and the other one is going to gain electron. They go hand in hand. Now, before we keep going with this redox, you're probably going to ask me is, why do I have to care about redox? Why do I have to care about redox? Well, you have to care about redox because a lot of reaction on a daily basis that you do involve redox. Batteries. Do you guys use batteries? Well, guess what? Inside a battery, there's a redox reaction going on. Do you drive your car? Combustion reaction. That's a redox reaction. Jewelry over time, they get tarnished. Why is that? Because of redox reaction. Okay, now do you want to know the most unfortunate redox reaction of all time? The most unfortunate redox reaction of all time is aging. Aging is a redox reaction. You kids are young right now, you probably don't care, but just wait. When you see your first wrinkle and you freak out, what are you going to be thinking about? Redox. That's what's causing my wrinkles. Now, let me give you, so this is what you have to care about, because a lot of things, including the aging, these are all redox reaction. Now, let me give you an example of a redox reaction. N2 plus O2 goes to 2NO2. And this reaction is going on in your car engine. So this reaction is going to be going on in your car engine. Okay. Now, when you do redox reaction, the key is you need to figure out what is being oxidized and what is being reduced. So this is a redox reaction that goes on in your car engine, but the key is we need to figure out which of these two are being oxidized and which of these two is being reduced, because redox is oxidation and reduction. In order to figure out what's being oxidized and what's being reduced, what we need to do, we need to figure out oxidation number. Again, I want to be very clear why you have to figure out oxidation number. You have to figure out oxidation number in order to determine what's being oxidized and what's being reduced. So, what do you think our next thing we're going to talk about? We're going to talk about what are these oxidation number, because we need to figure out oxidation number. Also, they call it oxidation state, in order to be able to figure out what's been oxidized and what's been reduced. Now, oxidation number or oxidation state what it does, it tells us the number of electron gained, lost, or shared when an atom forms a compound. So the number of electrons lost, gained, or shared when an atom forms a compound. So far, so good. Okay. Now, let's go over what this means. What are the oxidation number? I'm going to write a couple of examples. FeCl2. And what I want you to figure out, I want you to figure out the oxidation number of Fe and the oxidation number of Cl. Okay, so we said oxidation number is number of electrons lost, gained, or shared when an atom forms a compound. Because you know, when you form a compound, you got to compromise somehow, right? Now, FeCl2, what type of compound is this? This is an ionic compound. We have an ionic compound. For ionic compound, the oxidation number is the same as charges. That's really key. For ionic compound, oxidation number or oxidation state is the same as charges. And you are going to remember that for me, okay? Because again, charges will tell you how many have been lost, how many have been gained, right? So it's the same thing as charges. All right, now if I come over here, FeCl2, if I look over here, I know the 2 comes from the Fe, so Fe is plus 2, and Cl has to be 1, because again, you know, like we cross multiply the charges. Okay, so these are the charges, but the charges is the same as oxidation number for ionic compound. You guys got this down? Okay, perfect. Now, let's do another practice problem in that case. H2S, okay? I want to know the oxidation number of H and the oxidation number of sulfur. Okay, pause me, do this. Probably you say hydrogen is plus 1, sulfur is minus 2. And you are right, because this is an ionic compound. You can multiply, cross out the charges. So H is plus 1, S is minus 2. Ionic compound, the oxidation number is the same thing as charges. Don't forget that. Beautiful so far. Now, let me give you another example. NO2. NO2 is a covalent compound. And if you remember for covalent compound, there are no losing or gaining electron. There are no charges. There is no charges for me to cross multiply the charges. So it's covalent compound. There are no loss or gain electron, or usually sharing electron. Now to figure out the oxidation number is a little bit trickier when you have covalent compound. Now how do you do that? Here are the rules. Here's the rules. Here's how you would do it. Ready for the rules? Hydrogen is always plus 1, except when you have hydride. If you have hydride, it would be minus 1. Oxygen is always minus 2, except when you have peroxide. I'm not going to care too much about the exception in this class. Fluorine is always minus 1. 1A group is always plus 1. 2A group is always plus 2. So hydrogen is always plus 1. Oxygen is minus 2. Fluorine is minus 1. 1A group plus 1. 2A group plus 2. Okay? Now, and the sum doesn't have an E. Sum must equal 0 for a neutral compound, or it must equal an ionic charge for a polyatomic ion. Because if you remember, polyatomic ions are also what? Polyatomic ions are also covalent compound, right? Polyatomic ions are also covalent compound. So covalent compound and polyatomic ions, there are two nonmetals, there's no charges. So the way we do this, we have to use these rules to figure out for covalent compound and polyatomic ions. So far so good. Okay, let's do a couple of them right now together to figure out how to use these rules. Here's the first one we're going to do together. Let's do NO2. Okay, now the entire thing, this is a neutral compound. It would equal 0. Neutral compound, it would equal 0. Now we said oxygen is always 1. Oxygen is always -2. So oxygen is always -2. So I'm trying to figure out the oxidation number of oxygen and nitrogen. Oxygen will always be -2. But I need to figure out the nitrogen. So this one is -2. -2 times 2 is what? Is -4. So I just do a simple math. N would be +4. N would be +4. So far so good. Okay, let's keep going. Let's do a H3PO4. You ready? Okay. I want to know oxidation number of oxygen, of hydrogen, and phosphorus. Don't forget, oxygen is always -2. Hydrogen is always +1. Those one we know. Those one we know here. Those one we know. Now, phosphorus I need to figure out. Okay, so let's figure this out. The entire thing equals 0. Oxygen is -2. -2 times 4 is -8. Okay. 1 second. Let me be consistent with my... And then I have phosphorus. And you know that hydrogen is +1 times 3 is +3. Again, +1 times 3 because I have 3 hydrogen, +3 plus P, and then 2 times -2 is -8. So it ends up being equal to 0 because this is a neutral compound. So if I solve for P, I get +5. I get +5 when I solve for P. You guys feeling pretty good about this? Okay, let's do another one. We are on a row. Let's keep doing with this. SO4 -2. Okay, I want to know the oxidation number of sulfur and the oxidation number of oxygen. Okay. Now, the entire thing is equal -2. Oxygen is always, again, why before here I equaled it to 0. Now the entire thing has a charge. This is not a neutral compound because if you remember, if for a neutral compound the sum must equal 0. For a polyatomic ion, it would equal the ionic charge. And I will always give you the charge if there is a charge, right? Because if I give you an ion, I have to put a charge in there. Here, I didn't give you a charge for the compound, it's neutral. I didn't give you a charge for the compound, it's neutral. I gave you a charge, you're going to put down a charge. It's an ion, I have to give you a charge. Okay. Now, we know oxygen is always -2. That doesn't change. Oxygen is always -2. -2 times 4 is -8. And I can solve for S, and the S would be +6. So far, so good. Okay, let's keep going with this. You guys are doing really well. Let's do a couple more practice problems to make sure you understand it. H2SO4. I want the oxidation number of hydrogen, oxygen, and sulfur. Again, you know that oxygen is always -2, hydrogen is always +1. That doesn't change. I do need to solve for S. Now, this thing is going to end up equal 0 because I didn't give you a charge here. Here is the ion, I gave you a charge, no charge, 0. I know oxygen is -2 times 4 is -8. I don't know S. I know hydrogen is +1 times 2 is +2. So you have to come up with S, and S will end up being also +6. So S is +6. So far, so good. Okay. Let's do one more. Before we move on. So the other one I want to do is PO4 -3. Okay. The entire thing is equal -3. Okay. Again, oxygen we know always is -2. -2 times 4 is -8. Is a phosphorus that we don't know. We need to figure out. So phosphorus would be plus 5. Again, the entire thing equals 3 because I gave you a charge. Here, this is a neutral compound. I didn't give you charge. Here, I give you a charge. If I say ion, I give you a charge. You put the ionic charge right here. And then you know oxygen is minus 2, so that would be 8. And I don't know phosphorus. I can solve for phosphorus. So far, so good. So use these rules over here to figure out the oxidation number for covalent compound. All right. Beautiful so far. Very nice job. Now let's go back to what I had given you before, and that was N2 plus O2 goes to 2NO2, and we want to figure out what's been oxidized, what's been reduced. Okay? All right. What's been oxidized, what's been reduced. So we need to figure out assign oxidation number in order to be able to do that. Okay. Now, let's assign oxidation number. Let's come over here first. NO2 is a covalent compound, right? NO2 is a covalent compound. So, I need to figure out the oxidation number of nitrogen. Oxygen, I know, is minus 2. Oxygen is always minus 2, right? Now, I want to figure out the oxidation number of nitrogen. The entire thing equals 0 because it is a neutral compound. I don't give you a charge. And we know oxygen is minus 2 times 2 is minus 4. So nitrogen would be plus 4. Okay? So nitrogen over here is going to be plus 4. So far, so good. And oxygen is always minus 2. Again, we're figuring out the oxidation number for each atom. That's what we're trying to figure out. Assign oxidation number for each atom. And let's come over here. N2 has an oxidation number of 0. O2 has an oxidation number of 0. Why? Where did that come from? What happened when I said O is always minus 2? And you need to figure out the rest. Here's why. If you remember, these two are diatomic molecules. And we talked about diatomic molecules, right? We talked about diatomic molecules. We said diatomic molecules, that's how they exist in nature. When you breathe in oxygen air, it's actually O2. When you breathe in hydrogen gas, is actually H2. When you breathe in nitrogen gas, is N2. So this is how they exist in nature. So their oxidation, say the oxidation number is 0. You guys follow that? Okay. All right, so N2 goes from 0 to minus 2. And, oh no, it did not just do that. N2 went from 0 to plus 4. And O2 went from 0 to minus 2. So what happened to the N2? It went from 0 to plus 4. What happened to N? N became more positive. If you become more positive, what are you? You are oxidation. Now, what happened to oxygen? Went from 0 to minus 2. It got more negative. What happens if you get more negative? You are reduction. So far, so good. Okay. Now, I'm going to write this out one more time, and you should do it too. We have oxidation, and we have reduction, right? And oxidation is loss of electron. Reduction is gain of electron. Oxidation, you become more positive. Reduction, you become more negative, right? Okay, and you saw it over here, that nitrogen went from 0 to plus 4, 0 to minus 2. So those are the things. Now, I'm going to add one more thing to it, and that is oxidation, loss of electron, you become more positive, and you are also a reducing agent. Reduction, gain of electron, you become more negative. You are an oxidizing agent. What's going on here? So the agent are the opposite. Why the agent the opposite? Here's why. Let me see if I explain this. If I lose my electron, I am oxidation. But because I lose my electron, I'm causing you to gain those electrons. So I'm a reducing agent because I'm causing you to gain my electron. Okay, so if I'm losing my electron, I'm oxidation. But because I'm losing, I'm causing you to gain it, so I'm a reducing agent. so they are the opposite. And one thing I want you to remember, that the agent always have to be on the reactant side. The reactant are what's doing the act of oxidation on reduction. So if I go back over here, what is my reducing agent? My reducing agent would be N2, and this would be my oxidizing agent because they're the opposite. Okay, let's do another practice problem. All right, so our other practice problem, let's do another practice problem. Let's go aluminum plus copper nitrate. Okay, aluminum plus copper nitrate. Now, this is a single replacement reaction, right? Because you have one metal and you have a couple, they're going to, this is a single replacement reaction. In a single replacement reaction, the metals are what exchange. They replace each other, the metals, okay? So if that happens, so single replacement reaction, the metals are going to switch places. So what I get on this side, I get aluminum nitrate. And when aluminum forms a compound, then the charge becomes +3, right? Because now this is an ionic compound. So aluminum is going to go with nitrate. Nitrate is -1. Aluminum is +3. And then what's going to be left behind is copper. Okay. Now let me balance these reactions. I usually forget to balance things. Let me not do that. So 2 aluminum here, and then I would have 3 copper here, and then 2 aluminum here, and then 3 copper there. Okay. So we want to know what's been oxidized and what's been reduced. You ready to do this? All right. What's been oxidized and what's been reduced? Now, aluminum here, we have to assign oxidation number before we can do that. We have to assign oxidation number before we can do that. What is the oxidation number of aluminum? The oxidation of aluminum is 0. Why is it 0? Because aluminum is by itself. Anything by itself has an oxidation number of 0. It's natural, it's neutral in the nature. Okay? Now, over here, aluminum is forming an ionic compound. Now, when you have an ionic compound, you have to lose or gain electron to form a compound. An ionic compound charges is the same as oxidation number. Here, aluminum has a +3 oxidation number because, again, the charge of NO3 was -1, aluminum was +3. This is how this 3 came about. So I went from 0 to +3. I became more positive. What is that? That is oxidation. Now, let's look at the copper now. What's the charge on copper over here? Anything by itself, when it has no charge and is by itself, is not in a compound, the charge is 0. Copper metal has a charge of 0. Aluminum metal has a charge of 0. But over here, the copper now forms an ionic compound. When you form an ionic compound, it's a balance of charges. As you can see over here, is a copper plus 2. So copper went from +2 to 0. What happened to it? It got more negative. That is reduction. Okay. So again, when anything by itself alone has no charge, aluminum metal, copper metal, it has no charge by itself. But then when they form a compound, then they have charges, because when you form a compound, something has to give, right? And in this case, if you have an ionic compound, you can just go based on the charges. Now, here's my other question. What's the oxidizing agent? What's the reducing agent? We said they're the opposite. So this one, aluminum, got oxidized. So this has to be the reducing agent. And that means this one has to be the oxidizing agent. Again, agent have to be on the reactant side. Okay, let's do one more. Then that's going to make me feel better. Copper solid plus silver nitrate. Again, this is also a double replacement reaction. And then it goes to copper nitrate plus silver. I think it would be 2 silver and then 2 silver nitrate. So far, so good. Single replacement reaction. Why? Because again, I have a single guy, I have a couple, and then a single guy breaks up the couple. The 2 metals are going to switch places. Single replacement reaction. Okay. And then we said single replacement reaction is under redox. All right. So we want to figure out the charges, the oxidation, state the oxidation number in order to figure out what's been oxidized, what's been reduced. So we want to figure out the oxidation number in order to figure out what's been oxidized and what's been reduced. What's the charge in copper? Hopefully you can yell at me. That is 0, because copper solid by itself in nature has a charge of 0. Now over here is an ionic compound. Now it forms a compound. Ionic compound is the exchange of, you lose or gain electron. And this, to form this ionic compound, copper is now +2 because copper has to lose 2 electrons, right? So again, when you have an ionic compound, it's the same as charges, because ionic compound is a balance of charges. You lose and you gain, and copper has a +2 because it lost 2 electrons. So I go from 0 to +2. What happened to me? I am an oxidation because I got more positive. I went from 0 to +2. Now let's see what happened to silver. What happened to silver over here? Silver is 0 because it's silver metal. Anything by itself has a charge of 0. Now what happened to silver over here? Silver is +1 because NO3 is -1. This is +1, ionic compound. Same as charges, same as ionic compound. Charges are the same as oxidation number. I go from +1 to 0. I become more negative. What is that? That is reduction. Okay, yell at me. What's my oxidizing agent? Reduction. That means this is my oxidizing agent, and then this one would be my reducing agent. The entire reactant would be that. Now, probably you're asking, whoa. Okay, we figured out what happened to silver. We figured out what happened to copper. What the hell happened to nitrate? Now, nitrate is just a spectator. Nothing happens because the charge doesn't really change. But if you want to look at it, you can think about it this way. You can write a net ionic equation for it. I have a copper solid. Silver nitrate breaks up in water into 2Ag+, is soluble in water, breaks up into ions. Now, copper nitrate is also soluble in water, so it would break up into copper +2 and 2 nitrate. Again, look at the solubility rules, and that's just my silver. So far, so good? Okay, so I'm going to put AQ since they dissolved and broke up into water. Again, I can look at the solubility rules. This breaks up, this breaks up. These are just by themselves. So far, so good. Now, what can I cancel out? My spectator ions that are exactly the same on both sides are nitrate. So nitrate is my spectator ion. We've gone over that for double replacement reaction. Now, can I also cancel out the silver? You cannot do that because spectator ions are the ions that look exactly the same on both sides. But silver does not look the same on both sides. This is silver AQ is dissolved in water. This is silver metal. So they're not the same on both sides. You cannot cancel it out. The same here. This copper over here is copper +2 AQ. This copper over here is copper metal. This is a piece of metal. This is dissolved in water. It has a blue solution. So these two are not the same thing. So I cannot cancel those out. Now you can see over here what's going on. So copper, here it was 0. Here is +2, so it got oxidized. Silver is +1. Silver is 0 over here. So what happened is silver over here got reduced. This is another way to kind of look at it. And NO3, nothing really happens to it. It's kind of a spectator. I can cross it out because they look exactly the same on both sides. But silver and copper don't. Metal, dissolved in water, is in a solution. Now here, they exchange places. Now this is a metal and this one is dissolved in solution. Now before I let you go, probably you look at this reaction and say, whoa, this is the coolest reaction ever. Hopefully you said that. Why is this the coolest reaction ever? Check this out. You take a piece of copper, coppery color, you add it to a silver nitrate solution. What do you get? You turn the copper metal into silver metal. Isn't that so cool? That you can take a piece of copper metal that is not very expensive, coppery color, add it to silver nitrate solution, and then probably after 10 minutes, you're going to have a shiny silver metal. Magic, huh? That's kind of cool. And this reaction does happen. All right, so to summarize it, redox is cool, but also remember that redox is you have to look at the oxidation number and how the oxidation number changes to figure out who got oxidized, who got reduced, because redox is a transfer of charges. All right, very nice job. We're going to continue this next time and do more practice problem.